Section 2.1, linear equations in one variable. What does it mean to be linear and what does it mean to be an equation? Well, first of all, an equation, you're going to see an equal sign. What does it mean to be linear? We're going to learn about all kinds of equations in this chapter and in this course. So we want to make sure we understand the difference between linear, quadratic, absolute, radicals, all those kind of things. So linear will have a variable with a coefficient of 1. So let's see where we began. With constants, we had examples of like 3, 2/5, negative 5.7. Constants are kind of like your numbers. They're going to be constant. They're never going to change. And then we introduced variables. Variables were like your x and your y and your z and your t and your r, all those kinds of variables. And then we added to that and we said, okay, let's put constants and variables together to make expressions. And we did that by multiplication, addition, subtraction. So for an expression, we would say like 3x plus 2 or negative 1/5 y. Those are expressions. And then we created equations, and equations came by putting expressions equal to each other. So for example, 3x plus 2 equals 5. Now what makes this all linear? We have powers of 1 for our variable. X has a power of 1, y had a power of 1. Down here, all our variables had powers of 1, and that's where we get a linear equation. Now, any kind of equation can be true or false. If you solve it, then hopefully you're going to get a true answer. But let's see. So to solve linear equations, the first thing we want to do is we want to remove parentheses. Now, how do we remove parentheses? Well, that happens by doing the distributive law. Then we're going to combine like terms. Like terms are going to be like having the same variable raised to the same power that are on the same side of the equal sign. We don't want to start taking things across yet. We want to go ahead and combine anything that we can combine. Then we're going to get the variable on one side and numbers on the other side of the equal sign. So you just want to get variables on one side and numbers on the other side. And then we're going to divide if necessary. And why is it necessary? Is because we want to get the variable to have a coefficient of 1, and then we have solved for that variable. The great thing about this section is you can check your answers. Now I like to give steps, and hopefully if you follow these steps you'll get to the right answer. But again, once in a while the steps might lead you down a wrong road, so you might have to try something else. So let's think about these steps as we look at problems on the next. So we're going to solve and check. I'm going to do some of these with you and then I'm going to circle some for you to try on your own. Again, if you have time, always check your answers. Looking back at these steps, we're going to follow. Remove parentheses, combine like terms, and so forth. So on number 1, we do not have any parentheses. So now we don't have any like terms either that are on the same side. So the next step is to get the variables on one side and numbers on the other. So we're going to subtract the 6y to take it over, and that's going to give you 2y minus 2 equals negative 10. Then we're going to add 2 to take it over to the other side. We have to do the opposite when we're going across the equal sign, and 2y is going to equal negative 8. Then what do? Well, the last step was to divide if necessary, and we do need to divide because we don't have the coefficient of 1 yet. So we're going to divide both sides by 2. The left and the right, and we're going to end up with y equaling negative 4. So this is kind of like how I want to see your work. You don't have to show every step, but the more steps you show, the more possibility that I will give some partial credit on a test. So now let's check our answer. To check our answer, we plug in negative 4 wherever we see y. So we have 8 times negative 4 minus 2 is supposed to equal 6 times negative 4 minus 10. We don't know if that's true. We're hoping it is, but let's make sure it is. 8 times negative 4 is negative 32, minus 2 is negative 34. 6 times negative 4 is negative 24, minus 10 is negative 34. So it does check. So now let's look at number 2. We have 3 minus 5 parentheses 2x minus 5 equaling negative 2. Some students want to start off by taking the 3 minus the 5, but that's not what the directions tell you to do. Order of operations tells you to multiply in. And if you look back at our previous notes, First thing we want to do is remove parentheses by distributing. So we're going to distribute the -5. Be careful when it's a negative. So you end up with 3 minus 10x plus 25 equals -2. So I'm going to circle that, and I want you to finish that problem, but I will give you the answer. The answer is x equaling 3. Make sure you can get to that correct answer. So let's look at number 3. Also, don't forget to check. So on number 3, we have -5/3a plus 3 equals 23. I need you to really understand how fractions work, because chapter 7 is all fractions but with variables all over the place. So try not to use your calculator so much, because your understanding how to use a calculator is not going to help you in chapter 7 with fractions. So the first thing we want to do is subtract the 3. There are no parentheses and there are no like terms, so we move on to the next step, which is to get variables on one side and numbers on the other. Now please do not grab your calculator and just take 20 divided by -5/3. That does not help you understand what's going on. We want to make sure we understand how to get rid of fractions, and the way we do that is we multiply by the LCD. Now what do we not like? We don't like the 3 because that's what's causing the fractions. So we're going to multiply everything by 3/1. Again, I know some of y'all understand how to take a calculator and take 20 divided by -5/3, but that will not help you later on. So let's make sure we understand how to get rid of fractions. Multiplying by 3, those 3's cancel, and we get -5a equaling 60. And then the last thing we got to do is just divide by -5, and so a is going to equal -12. So again, make sure you understand how to use fractions without a calculator. So let's look at number 4. We have fractions all over the place, but let's try and follow the rules. The steps were to get rid of parentheses. We don't have any. Combine like terms. We don't have any. Now get variables on one side, numbers on the other. So I need to add 1/6x over here and add 3/4 over to the other side. Let's not worry about the fractions for now. So we have 2/3 x plus 1/6x equals 21/4 plus 3/4. So this already has a common denominator, so we can put those together. So we have 2/3 x plus 1/6x equals 21 plus 3 is 24 over 4, and that just becomes a 6. So we have 2/3 x plus 1/6x equals 6. Now what we need to do is combine these like terms. And how are we going to do that is by finding a common denominator. So the first number 3 and 6 can both go into is a 6. So let's go over here. We need this to become a 6, plus we need that to become a 6, and we still have equaling 6 on the other side. So this needs to become a 6. We had to multiply by 2. So 2 times 2 is 4. This is already a 6, so that can stay a 1, and then we have equaling the other side. Don't forget your x's. You can put them on top or you can put them out in front, either way, but do not put them in the denominator. So 4x over 6 plus 1x over 6 equals 5x over 6 equaling 6. So now, just like the other problem, what do we not like? We don't like the 6 down here because it's creating the fraction. So we're going to multiply both sides by 6 over 1. That will cancel the 6 on the left hand side, giving us 5x, and 6 times 6 is 36. So the last step is to divide if necessary, and it is because we don't have a coefficient of 1 yet. So when I divide by 5, I get 36 over 5. If my math lab asks for a fraction, you better give 36 over 5 or a mixed number, but do not give a decimal. So on number 5, I'm just going to circle for it for you to do. It's with decimals. I would definitely just use my calculator, and what would be the first step would be to distribute to get rid of parentheses. When you work that one out, you should get x equaling -41,900. So try that and make sure you can get to that answer. So let's look at number 6. So we have 12 minus 2 parentheses c minus 3 equals 11 minus 5 parentheses 2c minus 7. So first thing we need to do is get rid of parentheses. And how would we do that? By distributing. So we need to distribute the -2 and distribute the -5. So we get 12c minus 2c plus 6, because a negative times a negative is a positive, equals 11 minus 10c plus 35. Again, a negative times a negative is a positive. What do we do next? We combine like terms that are on the same side. So putting those together gives me a 10c plus 6 equals, we have these like terms that are on the same side, so 11 plus 35 is going to give me 46 minus 10c. So then what do? We get variables on one side and numbers on the other. So we're going to add 10c and we're going to subtract the 6. So that gives me 20c equaling 46 minus 6 is 40. And then what do we need to do? Divide by 20. So we're going to get c equaling 2. So before you try your homework, I would rework these problems and make sure you can get to the right answers. So now let's look at solving for an indicated variable. This actually is supposed to be, in a sense, simpler than what we just did because there's not going to be a lot of like terms we combine. But it is a little more challenging because we just have letters all over the place. So we definitely need to understand how do we solve for a specific variable. I always tell my students, highlight the variable that you're trying to solve for first. So we're trying to solve for r, and r is right in the middle of p and t. But what is that happening to p and t is just multiplication. So an opposite of multiplication is division. So all we have to do is divide by pt. So we get r equaling I divided by pt. Now I want to caution you on MyMathLab. If it's a capital, make sure you type in a capital. If it's a lowercase, make sure you type in a lowercase. It will not count it correct if you're not using the appropriate lowercase or uppercase. Alright, let's look at number 7. ax plus by equals c. Solve for b. Well, here's b, and we need to solve for it. So the first thing you need to do is get anything that's on the same side, not connected to the b, over to the other side. So we need to get rid of the a and the x. Well, opposite of, in a sense, addition is subtraction. So we're going to get by equals c minus a times x. And the last thing to do is to get b by itself, which is by dividing. So we need to divide by y and divide by y. So b is going to equal c minus ax over y. Now that's one way to write it. Some students might want to separate it. You could separate it as c over y minus ax over y, and that would be acceptable as well. So let's look at number 8. We have b equaling p parentheses 1 plus rt. We're trying to solve for p. Well, be careful. If you try and follow the rules from the previous page, distributing would be what you'd want to start doing. However, you don't want to do that here because you already have the p by itself almost. All you're doing is multiplying by 1 plus rt, and the opposite of multiplication is division. So we're going to divide by 1 plus RT. So be careful that you're looking at, if you already have one variable, and that's the one you're trying to solve for, don't distribute. So we end up with P equaling capital B, if you're typing this into MyMathLab, over 1 plus RT. Alright, so 9 and 10 are a little bit more challenging, so let's figure out why I say that. We have A equaling pi times S times capital R equals pi S times lowercase r. And the variable we're trying to solve for is S. Well, there's a problem. We have an S in this term, and we have an S in that term. So we have two S's. We don't have a way of solving when we have two S's when you cannot combine like terms, because those are not like terms. So what do we need to do? We need to factor out the S. So we have A equaling, factoring out the S from the first term would give you pi r, plus factoring out S from the second term would give you pi lowercase r. Those again are not like terms because one's a capital R, one's a lowercase r. So now we're back to just like we did on, because we have multiplication. So pi r plus pi lowercase r is what we're going to divide by on both sides. Pi capital R plus pi lowercase r. And that's what we end up with S equaling. So S is going to equal A divided by pi capital R plus pi lowercase r. So when you have a variable and it shows up more than once, think outside the box, which is like factoring. So on number 10, I'm going to circle it, which means you need to do it. And which variable are we trying to solve for? I'm trying to solve for x. So what do we need to do? You know what we need to do is to factor it out. So I'm going to give you the answer. Make sure you can get to it on your own. We have x equaling m divided by 3y plus 4z. Again, don't try and memorize the problem. Make sure you're understanding the concept.